4.10, number 493. We are supposed to evaluate the integral. Well, that means nothing more than find antiderivative for these indefinite integrals. We have 3x squared plus 2 over x squared dx. All right, so this looks like a quotient. There is no quotient rule in reverse, as I've tried to stress before. So the usual thing to do is, wherever possible, break it up into sums and differences. So right now, instead of looking at a quotient, let's look at it as a sum. So we will split this into 3x squared on x squared plus 2 on x squared. So here the x squareds cancel. And again, this is a common thing to do whenever the denominator is a monomial. This has been a binomial, right? Something plus something or anything like that. This would be much more challenging. But anytime it's a monomial, I should start looking at this kind of methodology, right? Splitting it up. And now we have 3 plus 2x to the negative 2. And of course I'm bringing that up here so I can use the power rule, the reverse power rule for integrals or antiderivatives here. So now it shouldn't be too much of a problem. We should get 3x. I need to raise this up by 1 to negative 1 and then multiply by the reciprocal of the new power. So it'll just be a negative 1 out here, really. Right? 1 over negative 1 is just negative 1 back again. So we get negative 2x to the negative 1. And that'll be plus c at this point because I have taken the antiderivative. And now all we need to do is rewrite this without negative exponents. We get 3x minus 2 on x plus c. That should be. So nothing like the other two problems. 482 and 483, where you had to think about chain rule. This one is simply just actually dividing, right? Divide the denominator into each of these separately and get two terms. Each one is really just a power of x.